And welcome back to Mission Control Houston. As mentioned a little bit earlier, I'm joined on console now by Tara Ruttley, one of our program scientists here for the International Space Station. So, Tara, thank you so much for joining me today.
Hey, this is going to be fun.
It's going to be a lot of fun. Okay. All right. Well, why don't we start off? Why don't you tell us a little bit about your history? So, where you grew up and how you ended up working here at NASA.
Sure. So I was born and raised in Louisiana, and I'd always wanted to work for NASA, and I'd always wanted to kind of be a.
You need to.
So I was born and raised in Louisiana, and I'd always wanted to work for NASA. Particularly, I'd wanted to be an astronaut. And when you're a kid, you think, oh, astronaut, big dreams, and that's the thing that kind of set me on my path. But growing up, people used to tell me, and students and teachers used to say, well, if you want to work for NASA, you have to get into engineering. It's got to be engineering.
That's right.
But then I got to high school, and two things happened. I got interested in biology when we dissected a cat. I know that's weird, but it was
Can't say
fascinating,
I ever
right?
got to do that in high school.
Exactly. So it was fascinating, and I learned a lot about physiology and the systems. The second thing that happened was I had asked an astronaut on a field trip to Houston. I said, the generic question I think they all get these days: what do you have to do to be an astronaut? And he said, just enjoy what you're doing, because not everybody gets to be one, and just enjoy what you're doing. And if you're a person who's fulfilled and enjoying your career, it'll all come through and it'll just work out fine. So I pursued my college degree in science and biology, to be specific. And then as I was moving along in college, I was realizing some of the experiments that I wanted to do needed some mechanical engineering interfaces and needed some design, and I was not capable of that. And that kind of stumped me, and so I decided to pursue my master's degree in mechanical engineering. And it was different, it's a change, but it was a good challenge, and it is exactly what I needed. And what I learned from myself was I'm a multidisciplinary person, and it's a good thing to be able to pull all those different fields together and produce something that means something to somebody, like an experiment and hardware that goes along with it. And then I participated in several of NASA's outreach activities as students. The graduate student research program I was a participant in. I participated in a few NASA's parabolic flight opportunities for undergraduates with some of my own experiments and my teams. And so I was really just involved in NASA. I was never actually a co-op because as a biology student, NASA didn't take co-ops. They only took engineers and business administration. But I was fortunate enough, just when I graduated with my master's, when I completed my master's, NASA reviewed my resume and there was an opening in the biomedical systems division, and it was a brand new division here at NASA, and that's exactly where I fit because I was so multidisciplinary. And then when I got to NASA, the PhD was the end goal for me all the time. I wanted to achieve that doctorate. And so when I got to NASA, I worked at NASA for about a year or two before I gave a good plan to my management, saying, here's how my dissertation or my research in an advanced degree would help NASA. And they agreed, and they were very supportive. So I pursued my PhD in neuroscience here locally at the University of Texas Medical Branch. And it was through the support of my management and really the entire NASA program and their belief in education and contributing, coming back as a contributor, that got me through that. And so I was pursuing my PhD while also doing biomedical engineering for space station. And what I did then was I helped to design and certify flight hardware that will be launched to space station for crew health. So things like a defibrillator or a respiratory support pack or just advanced medicine capabilities. My team was involved and responsible for that. I also did a little bit of engineering work related to the human research facilities that happen on space station, which is the experimental side of the hardware. And so I did that for about 8 years. And then, in 2007, 2008, I was kind of looking for a change after I'd completed my PhD. I was ready to do some science. And so I ended up here in the Space Station Program Science Office. And it's been a really, really great place. I've been here about 3 years now, and I'm just immersed in all the fun science that's happening on Space Station. And I tell you, I didn't even have a clue of what was really happening with regard to science till I got into this office. And and we've learned so much. And now to the day, I get to experiment and I get to play and understand and learn about all the different disciplines in the science that's happening on our orbiting laboratory up there. So what the advice I got was the best advice in the world. Follow what you love to do,
Hmm.
and I could not have even dreamed this up for myself. So it's just so fun being here.
So, like you said, definitely multidisciplinary stuff. Get into as many things as you can that you enjoy, and it'll turn out
Absolutely.
well.
Yeah, don't force anything, right? Just find what you love and do it. And you're right. And you'll be successful if you're doing what you love. So,
I actually came in through the co-op program,
oh
so
yeah,
NASA does have a lot of great educational programs to reach out to
absolutely.
universities, and they're always looking for new talent.
Absolutely.
So we showed some of your NEEMO footage a little bit earlier.
Oh.
So why don't you talk a little bit about your experience with that and how exciting that was?
Yeah, so when I was a new engineer, I learned about NASA's NEEMO mission, and that's the NASA Extreme Environments Mission Operations Program. So about once a year, NASA would send 3 astronauts and an engineer or a scientist. Actually, they'd been scientists until me. They would send to work underwater in an underwater laboratory about 65 feet deep to do space analog type missions. So to simulate what your days would be like in space, while it trained the astronauts for what it might be like to experience space by being extremely isolated and
Hmm.
running a timeline similar to what you'd see in space. And for the scientists involved, the scientists got to bring with them a whole suite of their experiments that they wanted to test out on the crew, and some of them were physiological, some of them were psychological. And I thought, as a young engineer who was working in biomedical hardware, I thought, why don't we engineering get involved in that? So I was new. No one was really going to shut me down too
Hmm.
early. I think my management was always so supportive, and they agreed. They said, let's give it a shot. So we proposed a mission to the project, and so our mission was in 2004. There were 4 of us. So there was myself, the first engineer, and then Doug Wheelock, Nick Patrick, and John Harrington, 3 astronauts, and we spent 10 days underwater off the coast of Florida, 65 feet deep in a laboratory, doing our experiments and training simulations for the astronauts. Now, typically, that habitat, which is called Aquarius,
Hmm.
it's run by NOAA. It's owned by NOAA, and usually it's used by the marine biologists year round. Marine biologists will write proposals to come and live in the habitat for days and investigate the coral reefs that are protected in the area. So it's a real functioning scientific laboratory, and then NASA will interrupt once a year or so with us and all of our gear and get a space analog mission in. And so that was really truly fascinating, especially as a young engineer. I mean, to be able to create a set of new hardware or gain ideas from others, and that everybody brings their hardware to the table, and then you're kind of crammed underwater for 65 feet deep for 10 days with 3 astronauts forced to use your hardware. You get some pretty good feedback on whether they might be good candidates for space.
Okay, and that NEEMO, again, an extreme environment like the International Space Station where it's really necessary to put these things to the full extent of what they're going to be able to do to really test them out.
Right.
So now let's switch over to a little bit of station science stuff. You obviously love what you do. You're very excited.
Yeah.
What are some of the more interesting science activities we have going on and things that you're really, happy to be involved with?
Yeah, one thing I think people don't realize is how many investigations are happening at any one given time. And right now there are almost 200 investigations or experiments happening on space station at any one given time. And
So a lot of work for the crews.
it's a lot of work for the crew, and it's the only laboratory ever in the world where you will find laboratory modules put together by in different disciplines. So, for example, nowhere on Earth will you see a material scientist lab with a cell biology lab and a human physiology lab, all fluid physics lab, all attached, because those people have nothing in common scientifically, really.
So again, multidisciplinary.
Multidisciplinary, and none of these modules were tested on the ground. They were all put together on orbit for the first time. So engineering, wonder itself, but as an orbiting laboratory, it's what it is. It's a laboratory, and all the research disciplines they span, across fluid physics to fundamental physics to human physiology and cell biology and technology development. Just you think of it, if it's affected by microgravity, it can be done. It's really fascinating.
Okay. Do you have a favorite experiment going on right now?
I do.
What is it?
Well, I have 2. One is a is the alpha magnetic spectrometer,
Okay.
and this is a big machine that sits on the outside of the space station truss, and it scans the skies for looking for cosmic rays and hits that could that could measure particles that could tell us a little bit about dark matter and dark energy, and maybe even tell us about a new form of matter called strangelets. So when you're trying to answer questions relating to dark matter and dark energy, it leads to things like trying to answer the questions of the origin of our
Mhm.
universe. Most of what we see is only 5% of matter that's in the universe, the stars, the planets. The other 95% we can't even see. We know it's out there. We want to find it and map it. The dark matter, and all that's going back to the Big Bang Theory, where an antimatter. So
Mhm.
where there was matter in the beginning, there should be equal parts antimatter. We obviously can see the matter. We can't see the antimatter. We're looking for it. So this machine's out there. It's constantly scanning the skies. It was developed by a Nobel laureate, and he's collecting data that's going to maybe find evidence for dark matter, antimatter, and a new form of matter called strangelets, which is strange in itself. But we haven't created that kind of matter here on the Earth, but we can theorize that it exists. So it's fundamental discoveries, and that part just fascinates me because it gets back to who we are,
Mhm.
and everybody wants to know that, right?
That's right.
We're all interested in that. The second one is quicker, I think, and it's an ongoing investigation about looking at how microbes respond in microgravity, and particularly bacteria and viruses. Some of them, not all, but some of them become more aggressive. They may replicate faster and be more just attackful in their nature, and it may in fact be a stress response to the microgravity environment. We care about that because of crew health,
Mhm.
and it's a closed environment on orbit, so we want to try to control that. But on the ground, we care about it for other reasons. For example, one team has found a gene responsible for creating the virulence in salmonella, and salmonella is the bacteria that causes food poisoning. So since we've been able to identify some of the causes of its aggression now, thanks to the microgravity environment, that team has been able to come back and develop formulated a vaccine that could potentially be used for food poisoning. And so that vaccine is in the initial phases of FDA approval right now as an investigational new drug. I don't know if you've ever had food poisoning.
I have, and it's not
You're
pleasant.
begging for a cure.
That's
It's
right.
it's not pleasant. So maybe one day it takes a while for these things to happen and get
Mhm.
through the FDA approval process, but I'm waiting. I'm looking forward to it.
I think everybody will be, but I mean, a lot of that what you just talked about just goes to show you have these experiments and this research being done on the station that has these, hardcore direct results that can be seen down on here on Earth, something like curing food poisoning. But then other end of the spectrum, the alpha magnetic spectrometer, these grand questions about where we come from, the origins of the universe, and what the universe is made of.
Yep.
So
Yeah.
vast array of things going on board the station.
Crazy cool.
Obviously, a
Yeah.
very exciting job.
Very exciting.
Well, Tara, I want to thank you very much for
Yeah.
being here today and give us a little bit of a look inside of the window of
Sure.
station science. And again, thank you very much.
Oh, you're very welcome. Thanks for having me. It's always fun to share it.
All right, thanks.
All right.